friends, in this video we will see the harmonic progression. Now what is meant by the harmonic progression? That is, suppose that the T1, T2, T3 are in the arithmetic progression, then the reciprocals of T1, T2 and T3, that is 1 upon T1, 1 upon T2, 1 upon T3, they form the harmonic progression. At the same time, also we'll see here in this video, also in this exercise, that is exercise 2.4, arithmetic mean, geometric mean and the harmonic means. Now the harmonic means what? Arithmetic means first, that is x and y are the two numbers, then am is equals to x plus y upon 2, then the given numbers are in arithmetic means, that is x, comma, a, comma, y, they are in AP. At the same time also we'll see the geometric means, x and y are the two numbers, then g is equals to in root of xy, then the numbers x, comma, g, comma, y, they are in the GP. Also we also see the harmonic mean, that is x and y are the two numbers, then h is equals to 2xy upon x plus y, and x, comma, 2x into y upon x plus y, comma, y, they are in the harmonic progression. Now let us see all the problems and some theoretical parts we'll see here. Now let us start the exercise 2.4. Now let us start the harmonic progression. Now see this harmonic progression, that is HP, it's a short form. A sequence T1, T2, T3 up to the Tn, Tn is not equals to 0. For all small n belongs to the capital N natural number is called harmonic progression if 1 upon T1, 1 upon T2, 1 upon T3 up to the 1 upon Tn forms an arithmetic progression. Means if we take the reciprocals of T1, T2, T3, then the 1 upon T1, 1 upon T2, 1 upon T3 form an arithmetic progression. Then T1, T2, T3 is in the harmonic progression. For example, suppose that 1 upon 3, 1 upon 6, 1 upon 9, 1 upon 12 is in HP, then their reciprocals, that is if we take their reciprocals, that is 1 upon 1 upon 3, 1 upon 1 upon 6, 1 upon 1 upon 9 and 1 upon 9, that is a 3, 6, 9 is in AP. Yes, they are in AP. Now see this here, the first term is 3, common difference is also 3 there, that is 6 minus 3, 9 minus 6, the D is equals to 3. Therefore, then what is the nth term of HP? Also it is very simple. Find out the nth term of AP and make its it's a reciprocal. Now here A is equals to 3, D is equals to 3. Therefore Tn is equals to A plus n minus 1 into D. Therefore 3 plus 3n minus 3. Now plus 3 and minus 3 get cancelled, and this is the Tn which is in AP. Now here we will make it a reciprocal harmonic progression, that is the nth term is 1 upon 3n. This is the nth term of the HP. Now the types of mean. Now see this. First mean is arithmetic mean. Second, AM, it is denoted by AM. Second is geometric mean. And third is harmonic mean. Therefore, now we will see one by one arithmetic mean. Now see the definition of this. If x and y are the two numbers, this is very simple definition. Only they find the mean of these two numbers. Their AM is given by A is equals to x plus y upon 2. This is the arithmetic mean, that is x, A, y form an AP. That whatever that mean and the two terms, that is x, A, y, they form mean. Now see this, their common difference, that is A minus x and y minus A. Then simplifying, you will get A plus A is equals to x plus y, and A is equals to x plus y upon 2. Now next is geometric mean. If x and y are two numbers having same sign, their GM is given by G is equals to in root of x and y. Now observe that x, g, y forms a geometric progression. That is, g upon x is equals to y upon g. Therefore, g square is equals to x into y. G is equals to in root of xy. Now next is harmonic mean. What is that definition? Its short form is HM. If x and y are two numbers, their HM is given by h is equals to 2xy upon x plus y. Then, that is, we observe that ax, h, y forms harmonic mean. Harmonic progression, that is 1 upon x, 1 upon h, 1 upon y is in then AP. Therefore, h1 upon h is equals to 1 upon x plus 1 upon y upon 2. Therefore, x plus y upon 2xy. Therefore, h is equals to 2xy upon x plus y. These are the very simple result. Now see this here, exercise 2.4. Verify whether the following sequences are HP. Now the first is 1 by 3, 1 by 5, 1 by 7, 1 by 9. Therefore, reciprocal terms are 3, 5, 7, 9. Here A is equals to 3. Common difference D is 5 minus 3, 7 minus 5. That is equals to 2. Therefore, this is 3, 5, 7, 9 is in AP and hence their reciprocals are in HP. That is 1 by 3, 1 by 5, 1 by 7, 1 by 9 are in HP. Now the second, 1 by 6, 1 by 3, 1 by 6, 1 by 12, 1 upon 24. Now make their reciprocals terms are 3, 6, 12, 24. Therefore, A is equals to 3, but the difference is not constant because 6 minus 3 is 3, 12 minus 6 is 6, 24 minus 12 is 12. The difference is not constant. Therefore, 1 upon 3, 1 upon 6, 1 upon 12, 1 upon 24 are not in HP, harmonic progression. Third one, 5, 10 upon 17, 10 upon 32, 10 upon 47. Now their reciprocals. Reciprocals terms are 1 upon 5, 17 upon 10, 32 upon 10, 47 upon 10. Now here A is equals to 1 upon 5, D is equals to 17 upon 10, 1 upon 5, and overall you will get 15 upon 10. Next term, that is a 32 upon 10 minus 17 upon 10, 15 upon 10. The difference is constant. Difference is constant. Now next, find the nth term and hence find the nth term of the following HP. Now here 1 upon 2, 1 upon 5, 1 upon 8, 1 upon 11. The terms are that is 1 upon 2, 1 upon 5, 1 upon 8, 1 upon 11. These are the terms. Their reciprocals are 2, 5, 8, 11. 2, 5, 8, 11. Now the A is equals to 2, D is equals to 5, minus 2 is 3. Therefore, Tn is equals to A plus n minus 1 into D. We can calculate the nth term by using the formula of arithmetic progression. Therefore, Tn is equals to 3n minus 1. Therefore, the nth term of HP is the reciprocal, that is 1 upon 3n minus 1. Now we want to find out the eighth term. Replace n by 8, that is 1 upon 3 into 8 minus 1, that is 1 upon 24 minus 1. 24 minus 1 is 1 upon 23. Therefore, the eighth term of HP is 1 upon 23. Now next is, therefore, eighth term of HP is 1 upon 23. Nth term is 1 upon 3n minus 1. Now next example. Example number 2. 1 by 4, 1 by 6, 1 by 8, 1 upon 10. Therefore, 1 by 4, 1 upon 6, 1 upon 8, 1 upon 10. These are the terms. Now AP is 4, 6, 8, 10. A is equals to 4, D is equals to 2. Therefore, Tn is equals to A plus n minus 1 into D. Therefore, 4 plus n minus 1 into D. That is a 4 plus 2n minus 2. That is a 2n plus 2. This is the Tn is equals to 2n plus 2. Now, the nth term of HP is 1 upon 2n plus 2. Therefore, eighth term of HP is 1 upon 2 into 8 plus 2, that is 1 upon 16 plus 2, that is 1 upon 18. Eighth term is 1 upon 18. Now next is, this is the nth term, that is 1 upon 2n plus 2, and the eighth term of the HP is 1 upon 18. Now third example, 1 by 5, 1 upon 10, 1 upon 15, 1 upon 20. Now the terms are 1 by 5, 1 upon 10, 1 upon 15, 1 upon 20. Therefore, the terms is APR, terms in APR, that is 5, 10, 15, 20. Therefore, A is equals to 5, D is equals to, common difference is 5. Therefore, apply the formula for the Tn is equals to A plus n minus 1 into D. That is 5 plus in bracket n minus 1 into 5. That is 5 plus 5n minus 5. And hence Tn is equals to 5n. Therefore, the nth term of HP is 1 upon 5n. Therefore, this is the nth term. Now next is eighth term. That is n is replaced by again 8. That is 1 upon 5 into 8. That is 1 upon 40. Therefore, eighth term of HP is 1 upon 40. Now next is, find AM of two positive numbers whose GM and HM are 4 and 16 upon 5 respectively. Now see this. Now we'll see first of all some basic theoretical part. If A, G and H are AM, GM, HM of two positive numbers X and Y, two positive numbers x and y respectively, then g square is equals to ah. Second, a is greater than equal to g is greater than equal to h. Now the proof of this, let a, g, now a, g and h be am, gm and hm. Their means, arithmetic means, geometric mean and the harmonic mean of the two numbers x and y. Therefore, a is equals to x plus y upon 2, g is equals to in root of xy, and h is equals to 2xy upon x plus y. Therefore, first RHS, that is AH, that is x plus y upon 2 and 2xy upon x plus y. A is for arithmetic means and the h is for the harmonic mean. If you make their product, then you will get xy is equals to g square, that is LHS, and hence ah is equals to g square. This is the formula. Next is consider a minus g is equals to, that is x plus y upon 2 minus in root of xy. Take 1 upon 2 is common, then 1 upon 2 in bracket x plus y minus 2 in root of minus 2 root of xy, and it is written as like this. X means what? Root of x bracket square. Y means what? Root of x bracket square minus 2 root of x into root y. Now what is happening here? This is the perfect square of root of x minus root of y bracket square, which is positive. Therefore, since the squares are always positive, therefore it is a greater than or, and it is non-negative number. Therefore, a minus g is a greater than or equal to 0. Therefore, a is a greater than or equal to 0. This is the first one. Now, a upon g is a greater than or equal to 1 since g square is equals to ah. Therefore, we can write it is like this, that is the g upon h is equals to a upon g, which is a greater than or equal to 1 from second. Therefore, g upon h is greater than or equal to 1. G is a greater than or equal to h from third. Therefore, from first and third, a is a greater than or equal to g, g is a greater than or equal to h, and hence it is a proof. Now see this our problem, that is the g square is equals to h. The value of g is 4, a is as it is, h is 16 upon 5. Therefore, now this is our problem, that is a is equals to 16 into 5 upon 16. Therefore, a is equals to 5. A is equals to 5. Next is find HM of harmonic mean of two positive numbers. Arithmetic mean and geometric mean are 15 upon 2 and 6. Here we have now see this. Find the HM of the two positive number AM and the GM are the 15 upon 2 and the 6. Now let A, G, H, P, their short letters, that is AM, GM and the HM of the two positive numbers respectively. Now what is the given condition? That is A is equals to 15 upon 2 and G is equals to 6. Now we have the formula G square is equals to AH. Substitute, therefore you will get H is equals to G square upon E, that is 6 square upon 15 upon 2, that is 36 into 2 upon 15, therefore H is equals to, that is a 24 upon 5. Now next is number 5. Find GM of two positive number whose arithmetic mean and harmonic mean are 75 and 48. Now again A, G, H, B, the AM, GM and HM of two positive numbers respectively, their short letters. Again we have the formula that is given. A is equals to 75, H is equals to 48, therefore G square is equals to 75 into 48, therefore simple calculation, 25 into 3, 48 into 3, that is a 25 into 16 into 9, their square root is 3 and 4, therefore G is equals to 60, that is G is equals to 60. Now next is problem number 6. Insert two numbers between 1 by 4 and 1 upon 3 so that the resulting sequence is a HP. Let H2 and H3 be two numbers therefore 1 by 4, H2, H3 and 1 upon 3. Now their reciprocals are 4, 1 upon H2, 1 upon H3 and 3 are in AP, means what? Arithmetic progression. Now T1 is equals to A is equals to 4 and T4 is equals to 3. Then what is the formula for arithmetic progression terms? That is that Tn is equals to A plus N minus 1 into D. That is therefore T4 is equals to A plus N minus 1, that is 3 is equals to 4 plus 4 minus 1 into D, and after calculation you will get T2 is equals to D is equals to minus 1 by 3. At the same time T2 is equals to A plus 2 minus 1 into D, therefore A plus D, that is equals to 11 upon D. Therefore T2 is equals to 11 upon 3, and that's why H2 is 3 upon 11. Also T3 is equals to A plus n minus 1 into D, that is a, at replace that, in place of 3 there must be the n, therefore T3 is equals to 4 plus 2 into minus 1 upon 3, and after calculations you are getting 4 minus 2 upon 3, that is a 10 upon 3. This is a T3, therefore H3 is equals to 3 upon 10. Hence required numbers are 3 upon 11 and 3 upon 10. And D is very short there. Now there is a correction in the answer of the textbook, but this is my answer. If we solve this, then you will definitely agree with this answer. Now next question number 7. Insert two numbers between 1 and minus 27 so that the resulting sequences is a GP. Let the two numbers be G2 and G3. Therefore, the numbers are 1, G2, G3 and minus 27. Now here T1 is equals to 1, which is the first term, and T4 is equals to minus 27. Tn is equals to A into R raised to n minus 1. Therefore T4 is equals to 1 into R raised to n minus 1. Therefore minus 27 is equals to R cube. And if we see this, that is a minus 3 into minus 3 into minus 3 means minus 27. Therefore R is equals to minus 3. Now the next is G2 is equals to T2, that is A into R raised to 2 minus 1, that is AR, that is a 1 into the value of R is minus 3. Therefore G2 is equals to minus 3. G2 is equals to minus 3. Now G3, that is a T3 is equals to A into R raised to 3 minus 1, that is a AR square, that is 1 into minus 3 raised to 2, that is a 9. Therefore G3 is equals to 9. Now the next is, hence the required answer is minus 3 and 9. Now the next is, next problem number 8. If arithmetic mean of two numbers exceeds their geometric mean by 2, and their harmonic mean by 18 upon 5. Find the numbers. Now see this, let the required numbers be A and B, and A, G, H be their arithmetic mean, geometric mean, and harmonic mean respectively. This dialogue you have to write every time for this type of the problems. Therefore, A is equals to A plus B upon 2, arithmetic means. G is equals to in root of AB, and H is equals to 2AB upon A plus B. Now, by given condition, A minus G is equals to 2 and A minus H is equals to 18 upon 5. Therefore, equation 1 minus 2, A minus G is equals to 2, A minus H is equals to 18 upon 5. Now, equation 1 minus 2, subtraction, A get cancelled, therefore you will get H minus G is equals to 2 minus 18 upon 5, that is a 10 minus 18 upon 5 minus 8 by 5. Therefore, H minus G is equals to minus 8 upon 5. Therefore, H is equals to G minus 8 upon 5. This is equation number 3. Also, A minus G is equals to 2. Therefore, A is equals to G plus 2. This is equation number 4. Also, we have the one relation, that is the G square is equals to AH. Now, substitute the value of A and H. Therefore, you will get whole equation in terms of G, and it is a quadratic, it's a normal equation, that is G square is equals to G square minus 8G upon 5 plus 2G minus 16 upon 10. Now see this, I am making small mistake, also I am making their correction also, that is a 2G minus 8G upon 5, that is a 16 upon 10, which is 8 upon 5, that is a 10G minus 8G upon that 5 get cancelled. See this, small mistake is there done by me, I am making the correction also. This is a 16 upon 5. Next is 16 upon again 5. Therefore, next is that 5 get cancelled on both sides. Therefore, 2G is equals to 16. Therefore, G is equals to 16 upon 2. Therefore, G is equals to 8. Next is H is equals to G minus 8 upon 5. That is 8 minus 8 upon 5. That is a 40 minus 8 upon 5. That is a 32 upon 5. This is H. Therefore, also A is equals to G plus 2. That is 8 plus 2 is equals to 10. Therefore, A is equals to 10. Now, G is equals to in root of AB. Therefore, AB is root of AB is equals to 8. Squaring on both sides, AB is equals to 8. square, that is a 64. AB is equals to 64. This is the long answer. Also, A is equals to 10. That is A plus B upon 2 is equals to 10. Therefore, AB is equals to 20. Now, substitute the value of B, which is 64 upon A. Therefore, A plus 64 upon A is equals to 20. Multiply on both sides by A. Therefore, you will get A square plus 64 is equals to 20A. Therefore, A square minus 20A plus 64 is equals to 0. Therefore, A minus 16 and A minus 4 equals to 0. Therefore, the value of A minus 16 is equals to 0 and A minus 4 is equals to 0. A is equals to 16 or A is equals to 4. When now we know that is A is equals to 16 or A is equals to 4. When A is equals to 4, B is equals to 16. Therefore, because A plus B is equals to 20 and hence the required numbers are 4 and 16. Now next, problem number 9. The answer in the textbook is different from my answer, and whatever that I had solved, that is correct. Find the two numbers whose AM, arithmetic mean, exceeds their geometric mean by 1 upon 2 and harmonic mean by 25 upon 26. Now see this. Now write the regular dialog, that is the required numbers B, X, A and B, A, G, H, B, their AM, GM and HM respectively. Then A is equals to A plus B upon 2, G is equals to in root of AB and H is equals to 2AB upon A plus B. Therefore, by given condition, A minus G is equals to 1 upon 2. This is equation number 1. A minus H is equals to 25 upon 16, 25 upon 26. This is equation number 2. Therefore, equation 1 minus equation 2, you will get A minus G is equals to 1 upon 2, A minus H is equals to 25 upon 26. Therefore, H minus G is equals to 1 upon 2 minus 25 upon 26. After solving, you will get that is minus 12 upon 26 minus 6 by 13. Next is, therefore, H is equals to G minus 6 upon 13. This is equation number 3. Next is also A minus G is equals to 1 upon 2. G is equals to A minus 1 upon 2. Again, see this. A is equals to G plus 1 upon 2. This is the fourth one. But the G square is equals to H. Substitute the values, value of A and value of H in terms of G, that is a G plus 1 upon 2 and G minus 6 upon 13. Make their multiplication G square minus 6g upon 13, g upon 2, and last is minus 3 upon 13. That is g square get cancel on both sides. I want to write g square on the left hand side, but it is only the g. It's a small mistake. Therefore 0 is equals to minus 6g upon 13 plus g upon 2 minus 3 upon 13. Now evaluate this. Find out the value of the g. That is 6g upon 13, g upon 2 is equals to 3 upon 13. That is minus 12g upon 13g upon 26 is equals to 3 upon 13. And that's why g upon 26 is equals to 3 upon 13. And therefore the value of g is 6. Now again, g is equals to in root of ab, and therefore in root of ab is equals to 6. Squaring on both sides, you will get ab is equals to 36, and therefore also a is equals to g plus 1 upon 2. Therefore 6 plus 1 upon 2, that is a 13 upon 2. A is equals to 13 upon 2. But also a plus b upon 2 is equals to 13 upon 2. It is a arithmetic mean. A plus b is equals to 13 and ab is equals to 36. Therefore b is equals to 36 upon a. Substitute the value here. A plus 36 upon a is equals to 13. Multiplying on both sides by a, then you will get a square plus 36 is equals to 13a. Therefore a square plus 36 is equals to 13a. Therefore a square minus 13a plus 36 is equals to 0. And the factors are 9 and 4. Therefore a is equals to a minus 4 is equals to 0 or a minus 9 equals to 0. But when a is equals to now, the required numbers are 4 and 9. In this way, we have completed the exercise 2.4. I hope that you have understood all the problems, whatever that I had explained here. If you like it, then like it also. If you are new for this channel, then subscribe it and share it with your needy friends. Now we'll see in the next video. Till then, goodbye.